Are you tired of building to-do lists? Let's be real. If you're an experienced developer, you've probably hit the ceiling of all the basic tutorials out there. The real challenge, the fun stuff, is architecting a scalable, data-driven dashboard that can handle thousands of updates a second without even breaking a sweat. In this explainer, we are diving deep into the complete blueprint for building exactly that. Our guide on this journey, Architect Aris, kicks things off with this core idea. And it's so important. If you're coming from the world of jQuery or just plain old JavaScript, you're used to having the freedom to just reach into the page and change whatever you want. Well, in React, that freedom is actually a liability. To build something truly powerful and maintainable, we have to embrace the structure React gives us. It's not a limitation, it's a prerequisite. So here's our game plan. We're going to start with that foundational mindset shift. Then we'll move into the nuts and bolts of state management and how we transport data. And finally, we'll get into some really cool advanced patterns for handling real-world complexity. Let's get into it. All right, first things first. We have to talk about this crucial mental shift. We're not just building a static website here. We are architecting a living, breathing, reactive system. And that means the old way of thinking, reaching into the page and manually changing things, we have to completely unlearn it. This slide really gets to the heart of it. In the old world, the web page itself, the DOM, was our source of truth. We'd literally check if a button had a certain class to figure out what was going on. But in React, our application state, just a JavaScript object, is the single source of truth. The UI, the entire web page, is just a reflection of whatever is in that data. We don't tell it how to change step by step. We just declare what it should look like based on the current state. Okay, so let's dig into that idea a little more. How does React actually manage this whole state-driven world? Well, it all comes down to its core update cycle. This right here is the engine of React. When your state changes, React doesn't just throw away the whole page and redraw it. No way. It creates a new virtual blueprint of the UI in memory, compares it to the old one to see exactly what's different, a process they call diffing, and then it performs the absolute minimum number of surgical updates to the real DOM. It's like a master surgeon instead of a wrecking ball, and that's why it's so incredibly fast and predictable. And this example just perfectly illustrates what I call the jQuery hangover. Look at the bad example. Manually grabbing an element and disabling it. Yeah, it works, but it totally breaks React's brain. You've just made a change that React has no idea about, and now its virtual world is out of sync with reality. The React way? You tie the button's disabled property directly to a piece of state, like isSaving. When isSaving becomes true, the button disables itself. The UI is always perfectly in sync. Okay, so our components can manage their own little worlds, their own local state. But what about the big picture? How do we share data across the entire application, especially when it's coming from a single live WebSocket connection? For that, we're going to need a data teleporter. Before we get to the solution, let's talk about the enemy. The enemy of any scalable React app is something called prop drilling. This is when you have to pass a piece of data down through like 5, 10, maybe even 15 layers of components that don't even need the data, just to get it to that one tiny component at the very bottom that actually does. It is messy, it's inefficient, and it's an absolute nightmare to maintain. And React's solution is so elegant. It's called Context. And honestly, the best way to think about it is as a data teleporter. We just wrap our entire app in a provider that holds our global data, like our WebSocket connection. And now any component, no matter how deeply nested it is, can just tap directly into that provider and get exactly what it needs. No drilling required. It's a game changer. Now, this is a super critical architectural decision. Why would we use a useRef for our WebSocket connection and not the useState hook we've been talking about? Well, remember, state changes trigger re-renders. If our WebSocket connection itself was in state, every single message we receive could potentially force our entire app to re-render. That would be a disaster. A useRef, on the other hand, holds a value that persists across renders without triggering them. It's the perfect tool for something stable and persistent like a connection. So, we've got our global connection. It's stable. But now we have a new problem. A raw WebSocket connection is like a chaotic data fire hose, just blasting information everywhere. If every single component tries to listen to every single message, our performance is going to grind to a halt. We need a traffic controller. The solution is a classic pattern called publish-subscribe, or what you could call a hub-and-spoke model. It's simple. When a component appears on the screen, it registers itself with our WebSocket hub. It basically says, hey, I'm GraphView 1, and here's the special function you should call when you get a message just for me. Then, when a message arrives, the hub acts like a smart router. It looks at the message's destination ID, finds it in its list, and calls only that one specific function for that one component. It turns the fire hose into a targeted delivery system. But here's the trap. This is where people get into trouble. What happens if you forget to unregister that listener when the component is removed from the screen? Well, you get a zombie listener. The hub is still holding onto a function for a component that doesn't exist anymore. When new data arrives for that ghost component, your app tries to update something that isn't there, and that leads to memory leaks and eventually crashes. This is why that little cleanup function in useEffect is absolutely 100% non-negotiable. All right, our core architecture is solid. It's robust. Now, let's really push it to its limits with two advanced real-world challenges: integrating with third-party libraries that also want to control the DOM, and building truly dynamic, flexible user layouts. So here's the fundamental conflict. React's whole deal is that it wants to be the sole owner of the DOM. But powerful visualization libraries like D3, well, they also want to own and directly manipulate the DOM to draw all their cool charts and graphs. If they both try to drive the car at the same time, you're going to crash. So who wins? The answer is a peace treaty. It's an elegant solution called the DMZ pattern, as in demilitarized zone. React's job becomes super simple. It just renders an empty container, like a div. Then it uses a ref to hand over total control of that container to D3, and it effectively looks away. It promises not to touch anything inside. This gives D3 a safe little sandbox, where it has full permission to do its magic, and React doesn't interfere. It's a beautiful separation of concern. And finally, how do we stop our dashboard from being this rigid, hard-coded thing? We use something called a slot pattern. Instead of writing our components directly into the code, we map over a configuration object, a piece of data. This completely decouples the layout from the logic, and it lets us dynamically render, reorder, or even A/B test different dashboard widgets just by changing a simple configuration file. It's incredibly powerful. So to wrap this all up, let's just lock in these three final principles that are going to save you from writing spaghetti code. First, keep your state as local as possible. Only share what absolutely must be global. Second, enforce strict data contracts on your messages with TypeScript. Don't guess what the data looks like. And third, give every part of your system a single, clear responsibility. Following these rules is the key to a system that you can actually maintain a year from now. And this last quote from architect Aris, it just nails it. Loosely coupled, but highly synchronized. We've built a system where the rendering engine, the data transport, and the complex visualizations are all independent and don't need to know about each other's internal workings, yet they all work together in perfect harmony. That is the hallmark of a truly robust and professional architecture. So there you have it. We've just walked through the complete architectural blueprint for a high-performance reactive system. The patterns are here, the traps have been identified, and the guiding principles are crystal clear. The only question left is, what are you going to build with it?